This video will show you a new factoring procedure that we'll learn this year. It has to do with looking at four terms. And we've talked about GCF. GCF you can use with any number of terms. We've talked about difference of two squares. GCF for any number of terms. Difference of two squares or dots, you have to have two terms with a minus sign in the middle. Trial and error, A&M. We have to have three terms, and now we're looking at four terms on the screen. We can't combine anything, they're not like terms, so we're going to turn to a procedure called factoring by grouping. Well, grouping means that we're going to try to work with them two at a time. So let's take a look at these first two terms as a group, and then we'll look at these second two terms as a group. First group, the yellow group, we're just going to look for a GCF in there. And we do find a GCF. We find a GCF of 2x. And then we'll open and close our parentheses like we always do. We'll put that minus in the middle. And looks like we need a y in here. And we need a 1 in here. So we've just successfully factored that yellow group. Now we're going to move on to the blue group. And the attempt for the blue group is pretty easy to do. We want to see if we can recreate this y minus 1 in parentheses for the blue group. So what could we put in front of a y minus 1 that would get us back to y minus 1? Well, that's easy. That's just a plus 1. And what you'll notice on this first line of the factoring by grouping is that now between the black and the green we see we have something in common. What do we have in common? Well, it's that y minus 1 binomial. So we're going to treat that y minus 1 binomial as though it's a GCF between the black and the green. We'll write it out in front. We'll open and close big parentheses. We'll look what's left over. Well, if we took a y minus 1 out of the black, it leaves us with a 2x. And if we took a y minus 1 out of the green, it leaves us with a plus 1. And on this problem, there's no more factoring to do, so we'll circle that answer. You can verify this by foiling it out. When you FOIL it out, you'll get four terms that don't combine. As a matter of fact, the four terms you'll get are the ones you started with, so that will tell you that you did the problem correctly. Okay, a second example. Again, what we're doing is we're looking at four terms here. Nothing can be combined, so let's break it up into two separate groups. We'll have the blue group for the first two terms. We'll have the pink group for the second two terms. And let's see where this is going to take us. Work with the first half. Work with the blue group. Looks like I've got an x squared in common there. And we'll open and close the parentheses, bring down the plus in the middle. X squared times x would get me to x to the third. X squared times 6 would get me back to 6x squared. Now I'm going to work on the pink side, and on the pink side we're again attempting to come up with an x plus 6 and hoping that works, and we'll see what to do if it doesn't work. But I'm going to try an x plus 6. Is there anything I can put in front of the x plus 6 so that it would result in those pink terms? And as a matter of fact, a negative 1 when I distributed it would get me those pink terms. So I've successfully factored my first row. Now I'm going to look at that first row. I'm going to look at the black and look at the red. And as a matter of fact, they do have that binomial in common. I designed it that way on purpose. So I'll put that binomial that they had in common out front. I'll open and close my parentheses, and I'll ask myself what's left in the red, what's left in the black. Well, in the black I have an x squared left over when I take this out. In the red I have a negative 1 left over when I take that binomial out. In this case, I can't stop there, but this isn't anything new. I'm looking at difference of two squares here. So I'll bring down the x plus 6 that's not changing. I'll get busy factoring this as difference of two squares, x plus 1, x minus 1. Give a quick check. None of those factors can go any further, so we'll circle that, and that's my answer. In my third example here, I'm going to try doing the same thing. We're going to group the first two terms in pink. We'll group the next two terms in green, and we'll see what we come up with. If I look at the pink and I try to do a GCF on the pink, I can take an a out of there. It's going to leave me with a 4y minus x. I'm going to move on to the green, but remember my goal here in the green is to come up with another 4y minus x and then see if there's some number that I can put here that's going to get me back to plus 4cy. Well, I need a plus c here, When I distribute that, that'll get me to plus 4cy. When I distribute this, I get a minus cx, so that's all good. Notice that I have the two binomials in parentheses for y minus x, so they come out front as something in common, and that leaves me with an a plus c as far as the big parentheses are concerned. Again, to check this, I'm going to do a quick FOIL of this to see if it's all working out. I can do first terms for ay, outer terms plus 4cy, inner terms minus ax, and last terms minus cx, and you can check term by term. They're not in the same order, but that doesn't matter because you can move those terms around and still end up with the same result.